So this is an example of a spherical nose, and this has been created using a revolve. So if I go and query edit this, you can see the history in there, the parameters it's been created from, and there's a curve here that's actually just been revolved around the z-axis. So if I go and look at this point here, you can see we've got triangular surfaces, 4 of them, and this is not allowed. So in order to pull that back from that corner, we can just simply take the curve that we used as a generation curve and shorten it slightly, so we end up with this. So now we've got 4-sided patches, 4-sided surfaces, and we just need to fill this hole. Now the obvious thing to do there would be just to put a square in, and we would then end up with another surface which is also degenerate, in the sense that the corners of that surface, that one, that one, that one and that one, would all be 180 degrees. Again, not allowed. And so we have to do something different there. So one option is to just put in a surface which approximates this area. So we could go, for example, edit point curve. So I'm going to make it degree 5, so we can have curvature continuity here. And we'll go from this point to this point, and then we'll go from this point to this point, and then we can align that to the edges. So we'll align that in G2, and the same on that side, and we can do that there, and we can do that into there, and then hopefully those curves will cross over in the middle. They should do, because it's all symmetric, and we should be able to do a rail between those. So let's go and do that. So that creates us that rail surface. I want natural on, that's usually the thing to do. So that gives us that natural shape there. It's rather high in terms of number of spans, and the reason is because of the way I've created it. I've created it from a generation curve which is in the middle, so we've got 2 spans rather than 1. We can reduce that here, so it will destroy the history, that doesn't matter, and then we can just extend that in all directions. So we'll extend that way, and we'll extend that way, so it now covers the whole. And what would be interesting to look at is how far this edge is from that center surface there. So let's go into locators, and we can measure between the curve and the surface, or the edge and the surface. Now it should be identical on each one, so let's try that again. There we are, 0.173, so not very far away. And so we should be able to, and we'd expect this to be the same because it's all symmetric, so 0.173, and that one all the same. I can get rid of these curves here because they're a bit confusing, but we're seeing those in the middle. So we've now got this surface in here, and we can then align these surfaces because it's a revolve originally. We actually would only need to align one of them, but I'm just going to go around and align all of them, and I'm going to project them up in the Z direction. So project in the Z. So I'm going to go align that. It will break the history, of course, and we do that. So the change there will be very small, and then I'm just going to do that on all of these. Like I say, because this is a revolve, we could have just taken one of those and revolved it around, or rotated it around, made copies of it. But in general, if this isn't quite spherical, then that obviously wouldn't work. We'd have to align those. And then we want to check the continuity between each of these. So this is going to be G2, and there's no reason to think that that won't be G2 because we've done a symmetric operation on this. And then the only thing left to do is just to trim out that surface in the middle. So we'll go into trim, not trim convert, of course. We don't need project on because we've got curves on surface here where we've projected or used a line with project on here. So we've got that, and then if I take all of the CVs off, you can see what we've got. So we've got this trimmed surface in the middle, and we've got the same shape that we started off with, but we've managed to get rid of the degenerate triangular corners.